Hello students, welcome to Solve Sir's classes. In this video, I will be solving the following question from IES 2015 paper 2. Now here we are given that x1, x2 so on till xn, they are the random sample from normal distribution with mean mu and variance sigma square where both are unknown. So our mu and sigma square both are unknown and we have to obtain the confidence interval for mu with the confidence coefficient as 1 minus alpha. Now we know that z, which is equals to x bar minus mu divided by sigma by root n. It follows normal distribution with mean 0 and variance 1, where this x bar, it is the sample mean, which is equals to 1 by n summation I goes from 1 to n xi. So x bar, it is the sample mean, and z, which is equals to x bar minus mu divided by sigma divided by root n. It follows normal distribution with mean 0 and variance 1. And next is n minus 1 s square divided by sigma square. It follows chi-square distribution with degrees of freedom as n minus 1, where this s square, it is the sample variance given by 1 divided by n minus 1 into summation I goes from 1 to n xi minus x bar whole square. So this s square, it is the sample variance given by s square is equals to 1 by n minus 1 summation I goes from 1 to n xi minus x bar whole square. Now we will get our t is equals to x bar minus mu divided by sigma by root n divided by root over n minus 1 s square divided by sigma square divided by the degrees of freedom, which is equals to n minus 1. So this is the degrees of freedom. So here n minus 1 will cancel out each other. Sigma will cancel out each other because when the sigma square will come out of square root, it will become sigma, and the sigma will cancel out each other. So this is equals to x bar minus mu divided by s divided by root n. Now it follows t distribution with degrees of freedom as n minus 1. So we will have probability that t is greater than equals to minus of t alpha by minus of t alpha by 2 comma n minus 1. So that t, the statistic t, it is greater than equals to minus of t alpha by 2 comma n minus 1 and is less than equals to t alpha by 2 comma n minus 1. This is equals to 1 minus alpha. Now if we substitute this t, we will get probability minus t alpha by 2 comma n minus 1. This is less than equals to x bar minus mu divided by s by root n, which is less than equals to t alpha by 2 comma n minus 1, which is equals to 1 minus alpha, which is our given confidence coefficient. So from here we can say that our x bar minus mu divided by s by root n, this lies in the interval of, or it is less than equals to t alpha by 2 comma n minus 1, and it is greater than equals to minus t alpha by 2 comma n minus 1. So from here we can say that this x bar minus mu, this is less than equals to t alpha by 2 comma n minus 1 into s by root n, and it is greater than equals to minus of t alpha by 2 comma n minus 1 into s by root n. Now from here we get minus mu, it is less than equals to minus x bar plus t alpha by 2 plus t alpha by 2 comma n minus 1 into s by root n, and it is greater than equals to minus x bar minus t alpha by 2 into n minus 1 into s by root n. Now if we multiply both sides of inequalities with minus 1, we will get our mu is greater than equals to x bar minus t alpha by 2 comma n minus 1 into s by root n, and it would be less than equals to x bar plus t alpha by 2 comma n minus 1 into s by root n. So from here we can say that 1 minus alpha into 100% confidence interval for our mean mu is given by x bar minus t alpha by 2 comma n minus 1 into s by root n, and x bar plus t alpha by 2 comma n minus 1, where this n minus 1 is degrees of freedom, into s by root n. So this is the 1 minus alpha into 100% confidence interval for our unknown mean mu.